Hey everyone, and welcome back to another Prep to Perfection Grade 12 Maths class. Just a quick reminder, if you boost your marks, you stand a chance to win 5,000 Rand. How amazing. Simply click the link down below to enter the competition. I'll now hand you over to your tutor, Camilla.
In this video for trigonometry, we'll be going over practice questions and solving problems. When solving equations, we can use general steps to help us. Step 1 is to start with the more complex side. Replace tan theta by sine over cos theta. Replace double angles or compound angles by single or reduced angles where possible. Thus, sine 2 theta by 2 sine theta cos theta. Lastly, cos 2x has three identities you can choose from. Look forward to what you must prove and choose the identity that will support the simplification to help you get the left side to equal the right side. As an example, sine 2x over 1 plus cos 2x equals tan. We'll start with the left-hand side, where sine 2x over 1 plus cos 2x. We get rid of our double and compound angles, so 2 sine x times cos x over 1 plus open bracket 2 cos to the power of 2x minus 1 close brackets. This will give us 2 sine x times cos x over 2 cos to the power of 2x. This gives us sine x over cos x, which is tan. So the right side. Solve for all values of x in the interval 0 degrees to 360 degrees that satisfy co-x equals negative 0.5. Cosine is negative in the second and third quadrant. In the second quadrant, cos is equal to 120. In the third quadrant, x is equal to 360 minus 120, which gives us 240 degrees. So our answer for x will be 120 or 240 degrees. Solve the equation for sine 2x equals cos x for x between 0 degrees and 360 degrees. If you recall double angles, sine 2x is equal to 2 sine x cos x. Substituting 2 sine x times cos x equals cos x. Factor out cos x. Cos x times 2 sine x minus 1 equals 0. Apply the zero product law. Cos x equals 0 gives us x equals 90 degrees or x equals 270 degrees. 2 sine x minus 1 equals 0. Sine x equals 0.5. This will give us x equals 30 degrees or x equals 150 degrees. Therefore, x can be 30 degrees, 90 degrees, 150 degrees, or 270 degrees. We are just going to go over area, sine, and cosine rule to help us answer two-dimensional and three-dimensional questions. If no perpendicular height is given, then we use the area rule. If no right angle is given, but we are given two sides and an angle that's not included, then a sine rule is used. If you are given two sides and the included angle, but no right angle, then it's the cosine rule. In the figure below, where point O is the center of the circle and the radius is R, BO is equal to OA equal to OD is equal to OC are all equal to the radius. Triangle AOB is equal to alpha and triangle DOA is equal to beta. Show that BC squared is equal to 2R squared open brackets 1 minus cos alpha close brackets and AD squared is equal to 2R squared open brackets 1 minus cos B. To start, we're going to determine the expression for BC and we'll use the triangle BOC. OB is equal to R, OC is equal to R, and triangle BOC is equal to alpha. We can use the law of cosine in the triangle BOC. Using the law of cosine, we get BC squared is equal to OB squared plus OC squared minus 2 times OB times OC times cos. In the triangle BOC, BC squared is equal to R squared plus R squared minus 2R squared times cos alpha. Then BC squared is equal to 2R squared minus 2R squared times cos alpha. BC squared is equal to 2R squared, open brackets, 1 minus cos A, which is our answer. Determine the expression for AD. Similarly, we can use the law of cosine in a triangle AOD, where OA is the radius and OD is also the radius. The triangle OAD is equal to beta. The law of cosine, AD squared is equal to OA squared plus OD squared minus 2 times OA times OD times cos. In the triangle AOD, AD squared is equal to R squared plus R squared minus 2R squared times cos beta, which equals 2R squared, open brackets, 1 minus cos beta. Therefore, BC equals 2R squared, open brackets, 1 minus cos beta, close brackets. And our final answer will be AD squared is equal to 2R squared, open brackets, 1 minus cos beta, close brackets. Answer. Determine the expression for AD. Similarly, we can use the law of cosine in a triangle AOD, where OA is the radius and OD is also the radius. The triangle OAD is equal to beta. The law of cosine, AD squared is equal to OA squared plus OD squared minus 2 times OA times OD times cos. In the triangle AOD, AD squared is equal to R squared plus R squared minus 2R squared times cos beta, which equals 2R squared, open brackets, 1 minus cos beta. Therefore, BC equals 2R squared, open brackets, 1 minus cos beta, close brackets. And our final answer will be AD squared is equal to 2R squared, open brackets, 1 minus cos beta, close brackets. We're going to now move on to three-dimensional problems. In the diagram, AB is a straight line of 1,500 meters. DC is a vertical tower of 150 meters high. With C, A, and B points in the same horizontal plane, the angles of elevation of D from A and B are 25 degrees, and theta, CAB, is 30 degrees. Determine the length of AC. Find the value of theta. Calculate the area of the triangle ABC. We are going to start by determining the length of AC. First, we need to use the information we have been given. We know that AB is equal to 1,500 meters, and the angle CAB is 30 degrees. Since C is on the same horizontal plane as A and B, I can use trigonometry to find AC. In the triangle ABC, we have AC is equal to AB times cos 30. We can sub AB in for 1,500, and cos 30 is a special angle, so we say AC is equal to 1,000 times the root of 3 over 2. This gives us that AC is equal to 1,500 times 0.866, and our answer is AC is 1,299 meters. Now we're going to find the value of theta. The angle of elevation for D from A is 25 degrees. The angle of elevation from D to B is theta. DC is 150 meters vertical tower high. I'll use the tangent of the angles of elevation to determine theta. I'll use the tangent of the angles of elevation to determine theta. For point A, tan 25 degrees is equal to DC over AC equals 150 over 1,299, which equals 0.1216. For point B, tan theta equals DC over BC, but I need BC first. Since C is between A and B, BC equals AB minus AC, which equals 1,500 minus 1,299, which equals 201 meters. Now tan theta is equal to 150 over 200. This equals 0.7861. Theta equals arctan, open bracket, 0.7816, close bracket. This will give us 38.2 degrees. Therefore, theta is 38.2 degrees. To calculate the area of the triangle ABC, I can use the formula area equals 1.5 times base times height. In the triangle ABC, base is equal to AB, which equals to 1,500 meters. Height is equal to AC times sine 30 degrees, which equals 1,299 times 0.5, which gives us 249.5 meters. Area is equal to a half times 1,500 times 649.5, which gives us the final answer of 487.125 meters squared. To calculate the size of the angle ADB, I will use the law of cosine, but first we need to find the lengths of AD and DB. AD will give us square root of AC squared plus DC squared, and this will equal 1,309.3 meters. BD will equal the square root of BC squared plus DC squared. This will give us 255.7 meters. Using the law of cosine, cos ADB is equal to open brackets AD squared plus BD squared minus AB squared over open brackets 2 times AD times BD. Cosine of ADB is equal to 1,309.3 squared plus 257 squared minus 1,500 squared over 2 times 1,309.3 times 255.7. This equals negative 0.7028, which gives us ADB equals the arc cos of negative 0.7028 equals 134.7 degrees.
Alright everyone, that's it for today. But don't forget to keep practicing so that you stand a chance to win 5,000 Rand. Click the link down below to enter the competition and we'll see you in the next class.